This is an example of how multiple whitewood systems can be used together to produce serviceable pallets. The process begins when a truckload of pallets arrive to the dock. The load is assigned a production number that can be used to track each of its pallets throughout the sort and repair process. A stack of pallets are placed on the infeed conveyor of an IVSys inspection system. The pallets pass through the IVSys system, where multiple cameras take pictures to determine the pallet type and the pallet grade. Pallets are graded as good to go, needs repair, or not able to repair. This information is stored in the database along with the date and time. Production number, pallet type, pallet grade, what needs to be repaired. Stringer, top end board, bottom end board, top middle board, bottom middle board. Pallets can also be manually fed into the sort and repair line. We can integrate manual inputs such as dock sorting, tipper sorting, and fork feed sorting. Pallets that need repaired are sent to the repair line and to an open repair bench. The repair bench operator has a touchscreen display that receives the pallet information, including what needs repaired and the pallet recipe. After repairs, the operator will confirm on the touchscreen that they have completed the repair. They can then change the grade and/or pallet type and place the pallet on the conveyor to send it to the stackers. From this elapsed time, we can record the production number, the time the pallet entered the repair bench, the time the pallet was returned to the line, the difference in those times, the individual boards that were repaired, and the pallet recipes consumed. This will allow us to give an individual repair cost to each pallet. Pallets determined to be good to go will be routed directly to the stackers, along with repaired pallets placed back on the line by the repair table operators. When the stacker is full, the stack of pallets is kicked to the stacker outfeed, and an AMR forklift is signaled to remove the stack and take it to the designated area in the warehouse. In the database, we will record the production number, the date and time it was stacked, pallet type, pallet grade, stacker assignment. Pallets that are deemed unable to be repaired by either the IVSys or the repair table operator will bypass the other areas and be routed to the robotic dismantler. In the database, we will record the production number, pallet type, the date and time it was dismantled. The RDS would route into the infeed of an urban sawmill or badger system. For a USL and badger, the following information is stored per board: date and time, inbound board length, width, and thickness, recipe match for final length, width, and thickness, stringer flags, reject codes, bin assignment. When the bins reach specific board count, a robotic forklift can be called to replace the bin of now raw material with an empty bin. For the entire production run, we now have the following information: the overall time for the production run, the total number of pallets, the number of good pallets that did not need to be repaired, the total number of pallets that need repaired, the total amount of time it took to complete the repairs, the amount of raw material that was used to repair the pallets, the total count of raw materials produced, the number of repaired pallets by operator, the acuity of the repair based on the components needing repair, the average repair time by operator, the total number of pallets that were destroyed. This information can be compared to the results of the USL or Badger system, and we can approximate a percentage of destroyed pallets that were salvaged. All of this data can be used to determine what type and grade of pallet can be produced and sold.